Welcome everyone. Today we are learning how to use the Pymol software. Basically, it's an app where we can visualize the chemical structure of a molecule. So the molecule right here is in a PDB file and is the hemoglobin structure. So let's get started. At first, our primary sequence is I'm going to show the primary sequence. So at first we go to the graphic system, we go to the display, and from this sequence, a sequence it means that it makes a complete um, amino acid sequence of how the molecule is made up of, and so this is how the molecule is made up of, and this is the whole amino acid sequence of this molecule of the hemoglobin structure. And then we need to show the structure in the line form. So, only this is the line form of the hemoglobin structure, and then comes the this is the ribbon structure, and then this is the stick structure of the hemoglobin, and at last it is the cartoon structure. So it's the helical structure is basically the cartoon structure. So how does it look when combining it's all three? So let's give it a check. So this looks a very complex structure when we are observing it in stick, line and cartoon form. So to find out the subunits in the hemoglobin molecule, we you visualize it with a color. So here are the four subunits: the pink, blue, the green, and the yellow. Now they are called the alpha 1, beta 1, alpha 2, beta 2 globulins also. So there are all total 4 subunits present, and if we check out the secondary structural elements, right, so this is how it looks. So basically the helix is red, the sheets are yellow in color, and the loops are represented by green. So you can see that there are no yellow colors. That means there are no sheets present in the hemoglobin, and in that case we only get to see helix and loop structures. So, as you can see, there are no sheets. In the earlier, I mentioned that the hemoglobin consists of 4 subunits, each of them present with each one cofactor that is called the heme group. It consists of iron as the central atom, and it binds to oxygen and helps to carry 4 oxygen molecules. So in the 4 subunits, you can see that there are the 4 heme groups present. I mean the 4 cofactor presence, and so this is how it looks like. Now we are going to find out the disulfide bond and how many are there. So at first we are going to hide all of them, because the disulfide bond cannot be seen like this. We need to make a little bit simpler figure. So I think in here we can see now the disulfide bonds in spheres. So you can see it's not visible actually. The two disulfide bonds are now visible. These are the two disulfide bonds, and this is how it look like. Okay, so this is the whole complete hemoglobin molecule. This is how the complex molecule is. It is. So now let us check their distance. Let us check the distance of any two atoms. So at first we are going to the wizard, then measurement. So we need to click on two atoms. Let us check which atom can I pick. It can be any two atoms. It's a random. So first let us make it all sphere so that we can visualize it easily. So this is one atom, and then this is another. Okay, these are the two atoms. So the distance between them are 5. These two atoms are 5.1 nanometer. Okay, so let us hide the sphere. So okay, so there are two distance that I calculated. One between these two atoms, one, and these two, the first one, and the second one is this one. So one is 2.9 nanometer, and another distance is 5.1 nanometer. So this is how the molecule is, and thanks for watching.